Hey everybody, welcome back to the no longer a mystery project. We got a little issue that we're going to have to deal with in this episode, so let me bring you guys in closer and let's have a look at the problem. If you remember where we left off in the last episode, we had to put this little collet adapter in here to use a mounted stone because we didn't have enough reach to get inside to do our internal boring without the back of the tool post grinder motor hitting the chuck. So it looked like that was going to be a solution, but I've run into another problem after doing a little more investigating, and that is that this collet adapter has about 5/1000ths run out. If I got it partially unscrewed right now, but if you run it all the way down so that it contacts the base, it straightens out a little bit, but it's still got more run out than you want. Okay, and I tried to see if there was something I could do to correct it. There's two issues. There's a problem in the collet area here. It doesn't really use a collet. It's got like three little fingers in there, kind of like a pin vise, except it uses a nut to tighten up. So there's an issue in there, and then I think the other issue is the bore in here, where it screws onto the shaft, spindle shaft. That bore is not true. Okay, now I did off camera come in with a tenths indicator, and I checked our spindle. It's dead straight. So the spindle is fine. Problem is this thing, okay? I think I can still buy these from Do More, but I'm not really crazy about the way it's made. I might try to make a better one, but that'll be another video, another project. So I think a better solution is we just make a Arbor extension so we can use a conventional stone and just get it extended out here about 1.5 inches or so. And I've got some 3/4 inch, I think it's just cold rolled stock that we can make one out of. So let's go that way. I think that's going to be a much better solution, more rigid, a larger diameter stone that'll hold up better. But we're going to have to do a couple side projects to make this, and also I need to make a threading tool for the lathe so I can thread the end of this thing when we get it turned down to 1/4 inch. Okay, so relatively simple part. We're going to drill, ream, and thread this end so that it can go onto the spindle of the tool post grinder. And then this end will have a spigot, a 1/4 inch spigot with the threaded end, 1/4 32. The challenge here is keeping everything nice and concentric, and also putting this 1/4 32 thread on there. Ideally, you'd want to single point it so that it would be nice and concentric with everything. But that's, I don't know. I think I'm going to use a die holder. Now, my die holder for the lathe is pretty rinky-dink, so I need to make a higher precision die holder. So that's going to be the first thing that we need to do. So let me show you my existing one and what the plan is to make that tool. So that'll be side project number 1. This is one of those side projects that happens when you're working on the main project. So I need to make a better die holder for the tailstock. This is my existing one, and I didn't make this. It just came in a box with a bunch of other junk. But I mean, it works, but it's, you know, it's got its limitations, and it's also a little sloppy. So we need to make a better one. I was rummaging around in my scrap pile and came up with these items. So this is a pivot post for a Volvo outdrive. So the entire outdrive pivots on this post, and it also, the seawater comes up through the center. Okay. the center bore is actually finished pretty nicely, so I don't think I have to do anything, which that's a huge time saver. And then there's enough meat on this end that I can clean this up and make a die pocket on this end. And then this will be the mandrel. I think I'm going to use this end to fit in here. I'll turn this down to the appropriate size and probably take that off, and then this I'll turn down, I don't know, maybe ½ inch or so for the spigot that goes in the chuck for the tailstock. Yeah, I don't know what this is. Somebody made this, and man, they did a heck of a job on it. It's got centers on both ends, nice hex on here, nice threading. I have no idea what it was. You know, like some type of push pin or whatever, but yeah, I mean, it's been in my scrap bin for like 5 years, so it's time to make use of it. I did do a file test. It is soft, so we can machine it. So let's get started. We're over at the old South Bend, giving it some love. I don't want to break down the setup in the other lathe. I'm going to clean this center up just a little bit. Probably enough. Alright, well, hopefully we don't destroy this insert with this interrupted cut. We'll take it slow at first. Alright, I'm going to double check that center height. Okay, it wasn't off by too much, but it was off. We're going to take 20 this time. Alright, we need to measure and see where we're at. I'm getting a 4/1000 taper, so I'm going to try to bring the tailstock toward me 2/1000. Okay, let's loosen this side first. That gave us almost a thou just loosening the other side. Okay. Okay, that should do it. Alright, I changed to a high-speed steel cutter with a little more nose radius, see if we can get a little better finish. Okay, we got 60 thousandths to go. We're gonna do it in 3 passes, 20 thousandths per pass. I'm going to measure again, see if we got rid of that taper. Okay, yeah, we got rid of that taper. We're within a thou. And we're going to take another 10. Okay, get another measurement. Okay, this should be the final pass. I'm going to take a real light pass. We're about 1.5 thousandths over. Well, maybe more like 2. Okay, that's 1/2 thou over. Let's check the middle. Middle's dead on. And this end is 1/2 thou over. Okay, so we need a little clearance, so I'm going to do a little file work. We're getting hit with a pretty good storm right now. It's really blowing up out there. The middle is closer, so I'm trying to work on the ends here. Yeah, so what I did, I measured the bore with the calipers and just re-zeroed it, so that way you don't have to do any math. And that's 0, so I need to take more off on this end. Alright, we're a little tight. I'm going to measure again, see if it's just this end or the whole thing. That tube has a little bit of internal run out, so I reset my calipers to the high spot. Okay, so yeah, looks like we gotta, just going by the high spot, we gotta take another 3 thousandths off. This end's not too bad. All right, I'm going to come back in and take 3 thousandths more. Well, it's a little looser than I wanted. I think it'll be okay though. It's got just a little bit of clearance in there. This tube is, it's got a nice finish on the inside, but I think it's a mandrel finish. I don't think it was machined, so it's got a little bit of inconsistency, but I think it'll be all right. Okay, I'm going to shorten this end up. I'm going to cut it off with the bandsaw right there because that's all we need for full engagement into a drill chuck. I'll make this 1/2 inch, and then we'll cut this little stub off the end here as well. Okay, next we need to take this down to a 1/2 inch in diameter. Okay, 2 more passes at 20 thousandths per side. Okay, it's got to face off this other end. Yeah, I was thinking it might be good to have a little counter bore in here. That would give us more clearance if you're trying to tap something that's fairly long. We're only going to go about 1 inch deep. Okay, our little mandrel is done. So that's actually a better fit than I thought yesterday, so I think that's going to be fine. I want to shorten this. I think that was out of frame, so do it again. I've got a little bit of a work holding challenge with this piece because of all these different diameters on here. Okay, there's no, I can clamp on here with the chuck and hold it with a large center. So that's what I'm going to do. So I can clean this up before we shorten our workpiece here. Okay, that's better. Yeah, this was set up for the other lathe, so it's center heights are pretty close between the two, but a little different. All right, let me engage the feed. This is stainless steel, so I'm going to start with a light cut just to see how it goes. Small diameter yet. Okay, let's see what happens. Pretty stringy. Now we're going to hit the larger diameter. Actually, no, it's a smaller diameter. Okay. Let me have a look here. Get this. Oh, some nasty chips. Same in feed. Yeah, I was afraid of that. Let me get some pliers. Okay, yeah, that was some nasty chips. So what I'm going to do, this little guy out of there, there we go. I'm going to come back up and pick up this diameter and then just do a final cleanup, and I think we can get a little chamfer on that at the same time. We got a pretty nice finish on that stainless. I'm going to hit this with some emery though, just to kind of bling it up a little bit. Okay, so we've got an issue here. I think it's going to be okay. I was hoping to give it a little cleanup cut, but this is a bearing race and it's hard. I thought this was all a one-piece deal originally, but it's, now that I can see it better, it's a little press-on sleeve. And we're just going to leave it on there. It's not going to hurt anything. I would like to get rid of this little flange, and I just checked it with a file. That flange is not hard, but this part is really hard. So I'm going to try to turn that off. I'm going to put it back in the chuck when we do that. Ah, it is two-piece. So this little flange piece is a separate piece. Huh, very interesting. And it's hard underneath. Wow. Let's see if I can put a little chamfer on there. Like my tool bit was loose. Huh. Okay. We'll do the rest with some emery. Okay, now we got to find out, do we have enough soft material in there to open that up for our die? Yeah, we're going to be fine. Okay. I went and dug another one of these out of my scrap pile and cleaned it up, and now I can see what's going on. So yeah, so you got a steel bearing race here, some kind of, alloy or carbon steel, hard, right? And then they put a stainless steel cap on the end, and it's a separate piece, as we can see from here. So when this is in operation, this part is exposed to seawater, and seawater actually comes up through the center. And then there's a seal that runs on here that goes to a water neck that goes up to the engine in the boat, okay? And then there's also a seal on the bearing, okay? So that's why they do this. They needed this to be stainless on the end, because it's exposed to seawater. All right, well, so this is steel, so I'm assuming this one is also steel. So I should be able to anneal this. Now this acted like it was soft, and then I hit a hard spot. Maybe it work hardened on me. So I don't know if that will anneal as well. So I'm just going to go ahead and put the torch to this and try to anneal it, because here's the dilemma. The inside is soft, so I can machine that out to fit our die, but I've got to get a couple set screws in here to hold the die. So yeah. All right, let me see if I can anneal this thing. Okay, let's give that about 20 minutes to cool down. All right, went and had a little snack break, and this thing's cooled down. And off camera, I cleaned the rest of this up a little bit because I'm going to want to put this whole thing in the mill vise when we go to put our set screws in here. Okay, and I did a little file check right here, so we're annealed. So let's go put this back in the lathe and continue on. Just going to make a skim cut just to try to make it look nice. Going to take just a couple thou. Take a little bit more. I don't want to take any more than we have to. Uh-oh. Well, best laid plans, right? So our annealing expanded that a little bit. So let's regroup. Gotta love these little quick projects that turn into a 3-day project. Okay, well, we annealed this bearing race, and we wanted to leave it on there because I need the thickness for some set screws. But it's lost its shrink fit. You know, it's expanded a little bit. I mean, it's still on there tight, but it's not tight. Okay. And when I tried to clean this up with a cut, it started slipping and moving on us, and I've tapped it back down. So I've been thinking about what to do, and I think I'm just gonna put a little weld bead, one on each side, and call it good. I thought about, you know, lopping this off, making a new collar, shrink fit, you know, but I mean, this is perfect. So I'm just going to put a couple weld beads. And the other thing is this end of the shaft has been swedged down, so it's actually thicker on the interior than the main part of the tube here. So that's good. It'll help provide more meat for our die right there. So that's what I'm going to do. I mean, this is steel to stainless, but I think it'll work if I use stainless rod, so we'll give it a shot. Well, that was absolutely terrible. It's going to hold, but not very pretty. I don't want to show you the one on the other side. My helmet kept cutting out. I know that's not an excuse. I'm definitely going to buy a better helmet. Those Chinese ones, even the good Chinese ones, just don't work for TIG. All right, here you go. Yeah, I know that's bad. So we'll clean it up a little bit in the lathe. Take another 10, then we'll remeasure. Still not getting a full cleanup. We're going to be really close once we do. Got about 44 thou to go. Okay, we got 24 to go. I'm going to split it up into two 6/1000ths per side passes.
Okay, it took a little.
Go a little deeper and clean up that bottom. Let's try a test fit. Okay, we're going to call that good. Well, I don't know how well this stainless is going to knurl. Hopefully this is not a train wreck. Let's have a look. Seems to be working. Well, it's not completely terrible. I hit it with a little bit of emery just to knock the roughness off. I think it'll be alright. We're probably going to be cutting this off somewhere in here. Okay, I was checking several of different brands of these round dies, and they're pretty consistent. They all use these little dimples. They're 180 degrees apart straight across, and then they use another one, a little pointed grub screw on the slot to adjust the thread depth, as you can see here. So I need to lay these out on our driver. Let's go over to the mill and have a look. I'm going to use this setup here with just a large V block. Our tube is too large in diameter to put in a spindexer, and I didn't want to break out the dividing head and go through the whole process of setting that up. So on our first two, we can just drill straight through. That'll give us our two that are 180 degrees apart. And then what I'm going to do, I'm going to come in here with our rose indexer. I'm doing this with one hand here, so I can come in here after we do the first two. I can put this on before taking anything loose, square it up. Obviously it's not square right now. Rotate the part, square it up again, and then I can take this back off, and that should do it for us. Number 21 drill bit for 1032 tap size. And now I've turned our indexing block around the other way because it has a smaller diameter here. So now I'm against the vise jaw rather than the vise itself. So that's going to work a little better. And we're just going to use a level. Level here. I'm going to level it. Okay guys, I ended up finishing this off camera. I just got to the point where I just wanted to get it done. And it takes forever when you're filming. So off camera, I added a couple of locations here for Tommy bars. Yeah, I just made these out of some bolts. Just cut them off, rounded the heads off. All right, and then of course you can see I also shortened it up. And I had to come in with the boring bar because our welding put a little bit of distortion in. So just a little skim cut with the boring bar so our mandrel slides nicely. And then let's just try a die on here. This is a 1/4 20. Okay. And the split goes up there. And I use set screws that have slotted heads, which is a little more convenient than having to look for a hex key. So this center one, with these split little mini dies, it gives you the ability to slightly adjust your thread. Okay, well there you go. Let's go try it, see if it works. Okay, I got a piece of 1/4 inch. It's actually a bolt with the head cut off. A little cutting oil. I'm going to try it without the Tommy bar, just trying to, holding it by hand, which is probably what I would do on small threads. See how far we get here. Yeah, no problem. I like it. That was easy. Wow. All right. Okay, I'm going to call that a win. We didn't even need our little Tommy bars. Cool. All right, let's go back to the bench. And of course, after going through all this effort, I did some poking around on the internet. You can buy these. Little Machine Shop has got a rather similar one for like under $40. Although I think it's aluminum instead of steel, but yeah. But what fun would that be, right?
Thanks everybody for sticking around. Sorry it was such a long video. We'll have to come back and make that little extension mandrel piece in the next video. So we will see you then. Thanks again, guys.